Hello everybody, today in geometry we will be talking about section 3.4, which has the topics of the following: convex set, postulate number 9, and also the definitions of half planes, edge, and opposite sides. And as you can see on the right hand side, I have a picture of a donkey because I am running out of pictures to actually put on the screen. So let's go ahead and get started. The first question I have for you is, what is the difference, or which one of the following shape does not belong, and then what question is why? Notice the four shapes that I have over here. One of those games that I usually like to play when I was back in elementary school days was on a TV show called Sesame Street. So they would have basically four shapes or four things on the board, and one of them is going to be different. So here it's exactly the same idea. Well, you guys can probably deduce that the one that is different is the one that is on the lower right-hand corner. And if I draw the following, maybe you can then give me more of a formal definition. Here, what I'll do is I'm going to go ahead and pick 2 points that are in the circle and then draw the line segment. Here, I can pick any 2 points in the triangle and then draw a line segment. Here in the square, I'll do the same thing. Maybe I'll pick any 2 points and then draw a line segment. But as soon as I get to this weird shape right here and pick 2 points over here specifically, and I draw the line segment, you'll notice now that is going to be something that's going to be different. So this is what is going to give rise to the definition of convex. So a set S is considered convex, or in this case, the shape is considered convex, if you pick 2 points in the set, if you pick any 2 points in the set, and form a line segment with it. If that line segment is in the set, then it's considered convex then. So writing it out, if point X and point Y are in the set, then that means that XY, the line segment, should also be part of set S then, okay? So one way to think about it is that it's kind of like closure, right? Because you're taking any 2 points in the set and then you apply to some operation, and that result should also be in the set then. All right, so now let's go ahead and take a look at some examples of some convex sets. So here in part A, you can see I have supposedly I have an hexagon. I have to draw it first, right? So here, if I draw a hexagon, that is considered a convex set because no matter any 2 points you pick and you draw the line segment, it's always going to be, that line segment is always going to be inside the hexagon. What if I had a line that goes on forever? Well, it's the same thing, right? On that line, if I pick any 2 points, A and B, you can see that AB is definitely going to be on that line. So yeah, that works out too as a convex set. Going a little bit further, what if I had a ray, right? What if I had 1 point that ends and the other one that goes on forever? Well, here it's still the same thing, right? Because if I take any 2 points on the ray, it doesn't matter where, you can see that that line segment of AB is still also on the ray. And finally, for the last one, what about if I have just a single point? Well, that single point, we're just going to have to choose the same single point twice to form a line that has a distance of 0. But the result is that it's still going to be that single point then, or inside that single point. So all of these are valid convex sets. Now, let's go ahead and apply the convex set to some of these geometrical figures that we have here. The conditions are going to be as follows. Let's say that we have a picture right here on the right-hand side where we have a plane that goes on forever. And what I'm going to do is I'm going to go ahead and say line L is going to be somewhere on that plane. And if I draw line L, you can see in my picture, as a result, we're going to divide the plane into two separate planes over there, or subplanes, I guess. We'll call it H1 and H2 because those are kind of like half planes then. You know, one half of the plane is up there, the other half is going to be down there. Now, so with that set up, here's what we're going to say then. Looking at the picture, you can definitely see these half planes that I created right there, they are considered convex, right? Because if you take any 2 points inside any of those half planes, the result is that it's going to be inside the half plane still. It's not going to be somewhere else. So that's the first part. The second part, well, now what if I pick a point that's in one of the half plane, we'll call A, and then we'll go ahead and find another point in the other half plane, we'll call B. If I draw that line segment that goes from A to B, well, obviously, we're not talking about convex in this case, but you can notice that the one relationship is that what does it do with line L? It intersects it. So that's going to be our conclusion then. So if point A is in H1, and if point B is in H2, then the result is that AB is going to intersect with line L. Okay, and you can go ahead and give that point a name if you want, but it's just going to be an intersection then. So this right here, that is what is known as postulate number 9. So we're definitely going to be using that in the near future. Now, what I want to do is go ahead and define some of these things that we just said. So first one is half planes. So the half planes are basically going to be the two sets that are formed by dividing that plane into the two parts with a line then. So here you can see that we have two half planes, H1 and H2. The next one is the term edge. And the edge is basically considered as that line that divides the two half planes. The edge, note that it is the intersection between the two half planes, so meaning that it's on both of the planes, H1 and an H2. So it's kind of like a borderline, basically. And then finally, the last terminology is opposite sides. So if point A and point B are chosen, such that A is in H1, like in the picture, and B is in H2, like say in this picture, then we can say that both those points are considered to be quote-unquote on the opposite sides then. So the last thing I have is, well, take everything that we just said, and what if we applied it into 3-dimension? Well, if we have space, for example, right, what can we use to divide the space into two spaces? What shape will we actually have to use then? The question number 2 is, are those two spaces then considered convex? And then finally, number 3 is, if I take a point in one space, and then if I take another point in the other space, right, the two quote-unquote half spaces, what is true about that segment PQ then in this case? So I'll let you think about that a little bit. Thank you so much for watching. I will see you next time then. Take care.